Mega Mechatronics.
Alright, these batteries are charged by 45 watts of Harbor Freight solar action up here to the controller, and I'm actually charging my bike right now. So we'll come over and follow this cord to the scooter charger here. This is a 1.5 amp scooter, 36 volt scooter charger. It's automatic. It's fairly lightweight, so I just attached it with some zip strips. The thing's pretty solid. Here's my DC to DC converter, so this takes it from 36 volts to 12 volts. It's rated at 5 amps. I'm running a 3 amp fuse, so it's pretty good, and that's going to power the solenoid, or the contactor for the main, for the motor, brake light, and any other accessories that I'll add in the future, like a headlight or anything like that. So here are my PowerSonic AGM batteries, 9 amp hour at 36 volts. And coming up here, we'll start off. Here's the kill switch and on switch, and also have a momentary on switch. I'll get to that later. Here's a cruise control and a little feedback light. And let's move around to the other side. Here's that 100 amp contactor. Do some work on this. Here's a safety cap. Got 36 volts coming out of there. So here is a cheap, really cheap scooter controller. The thing is, this works because the Kelly one I got didn't exactly work first time I used it, so I had to get this back up. It works, and I actually like it because this is rated at 1024. I'm running 1300 max, 36 volts, but usually about 900 cruise. Cruise about 18 miles per hour. All electric. You could see I chopped the crank off. I'm trying to keep this very inexpensive, so instead of purchasing a whole new bottom bracket, chain rings, in a one-way, I just took my angle grinder, zip it off, and save a couple $100 and some time. So here's a little automotive relay for the 12 volt to the little brake light here. This is a 3 LED trailer brake light. The thing pulls a couple amps. It's pretty bright, and so just a cheap stereo, fuse, whatever, thing works, and it's fuse excellent. So I got a lock mounted up here. I do some testing and go to the store or something like that. So here's the brains of this e-bike, and we'll start with the throttle. So coming here to the throttle, here's a Hall effect throttle from Kelly controller. This thing works pretty good. It's a little loose. It's not like a motorcycle when you have some resistance there. So it is pretty loose. When you go over bumps, you're going to be throttling it. But other than that, it works pretty well. And I do have cruise control, so that makes life easier. So the signal from the Hall effect sensor up there, it feeds into the Arduino. And the Arduino is going to process that, look at some parameters I have set, amperage limits, things like that. And it's going to get its signal from this Hall effect amp sensor right here, and you can see the two big legs coming off of there, and I had to solder some big eyelets on there, and that's the ground for the controller here, and that's where I'm taking the amp feedback signal. So the Arduino is going to process that, and then it is going to use a digital signal output to send a voltage to that scooter controller, and it works pretty well. And I have a safety brake switch. We'll come up here. Seen these in my other videos, and that's going to be for brake safety cutoff, as well as that runs the brake light system. I also have a little startup buzzer. We'll play with that later. Onboard 12 from the DC-DC, and then here's the 12 to 5 volt for some of these sensors and accessories, things like that. Little light sensor for the timing of the brake light blinking. There's a little automatic blink going on there, and so there's cruise control input as well. So let me go ahead and turn off the charger. And so in order to start this up, I got the kill switch, but it's not going to turn it on. The Arduino's not lighting up. I'll show you why. Got a little schematic here, and so you can see here's the main contactor, 100 amp, and that's going to feed the DC-DC converter, which is in turn going to go feed the contactor. But we need a momentary switch in here to bypass and charge this up so that the loop continues. And then when I do cut this off, and this will drain out its whatever stored energy it has in it, then you can't turn it back on without using that momentary switch to sort of get that fired up. So it was a little quick fix to get that going. So I'll show you here. I will turn this on, and I have a little momentary switch here, and that buzzer is a startup buzzer. That means it's been loaded, it's in its loop cycle. You can hear it clicking, and that is the brake light. And so if I do turn this off, there's actually some stored energy in that DC-DC converter. What I need is well, that light blinked on, but I'll put a capacitor in line so that you could probably leave it for several minutes and not have to do the momentary switch. So I turn that off, and so it's built with a cheap frame. The bike is a stock Walmart special. I think they're going about $160 these days. Full suspension, very cheap, very inexpensive. Fake rubber band forks up front. Pretty tiny gauge steel. There's play in between these two tubes here. If you hit the brakes, and the rear end here, this is really thin stuff. These mounts here. So if you want to compare that to a real mountain bike, this is a Weapon X downhill bike. This is my next new frame, so quite a bit more beefy. Disc brakes, excuse me. Got some hydro brakes in the front. What are these, 203mm or something? Got to get some rims. I'm going to look for some dual crown forks, but these are pretty Marzocchi dirt jumpers. Not too bad. 4 inches of travel, oil dampening with the preload, and so this frame is significant, a magnitude stronger than this little Walmart cheapo bike. And you can see the suspension travel in the rear. It's about 9 inches, and then the front is 4 inches. So I'd probably run this a little softer for the road, just for better ride quality, things like that. Let's see if I forgot anything else. Yeah. Show you my little high torque solenoid. I'm going to mount up an automatic transmission using this solenoid from Hobby King, about 20 bucks. So I'm going to figure out the mounting system for this, and that'll tie into the Arduino, as well as getting speed feedback, so I know it's a little better, easier to program shifting, and then playing around with that to find efficiency and things like that. along with the amp feedback, and then get some voltage, and I can do wattage meter, thing like that. So this is the bike so far, the X1E experimental bike. Very low budget, proof of concept, and sort of a test bed to a little playground before I get into the X2E over here, which I'll use my learnings from this first bike here and sort of permanently integrate them in a frame such as this Weapon X here. We'll see how it goes. Thank you for your time and checking out the Power Axle X1E and X2E.